Hi, so in this screencast I'm going to show you how to write an interface for some C++ code in an R package. And so yeah, in the last screencast what we did is we showed you how to compile some C++ code in an R package. And that's what we did. We have an implementation of this C++ code in a knn.cpp, this C++ code in the source directory of an R package that we created using the Rcpp package skeleton. But we haven't created any interface yet for this file, so for this function. So what we're going to do now is we're going to take this rcpp hello world.cpp file that was initially created by the rcpp package skeleton. And here I'm going to rename this to interface.cpp to be clear that this is where we're defining some interface functions. I'm going to open that up, and I'm going to create a new interface function called, here, let's go back to the other source code file, knn.cpp. So the first function we're going to interface is this, actually the main function that we want to interface is the second function down here called predict 1 to max neighbors matrix. Right, so predict 1 to max neighbors matrix, what is this doing? This is computing the nearest neighbors predictions for a whole matrix of test data points, and for a range of neighbors parameters, 1 to max neighbors. The max neighbors parameter is an input argument of this function. And so what this function is doing is it's just calling this predict 1 to max neighbors function a bunch of different times. And so the predict 1 to max neighbors function is the first thing that's defined up here, and that's defined kind of separately so that it's clear, like the dependence between what we're doing for each test data point, and so yeah, this function works for one test data point, and the second function it works for a whole matrix of test observations. So, but yeah, this is the main function that we want to interface. So what are we going to do to interface that? Well, so what we usually do is we create a function with the same name to predict 1 to max neighbors matrix, and then I do interface. And so this is going to be a function that's an interface to the C++ code. And so what are we going to do there? So what we can do is, well, we basically have to translate all of these arguments in our C++ code from double pointers and int pointers to our data structures, character vectors, and numeric vectors. So first thing that we can do is we can distinguish input and output arguments of our nearest neighbors function. So here the inputs are all the way up to here. Right, so inputs above, outputs below. It's always nice to clarify that when you have these kind of these C-style functions where here the return value is this integer status code, and all the arguments include pointers, which are pointers to input, some pointers to input data above here, and some pointers to areas of memory which we're going to use to store the output predictions. And so here what we're going to do is, for all of the input arguments, we're going to create corresponding arguments of our interface function. So what we can do is we can create a numeric vector for this double pointer, or actually a numeric matrix, right? Because this double pointer here, train inputs pointer, is actually a matrix of all of the train inputs. It's ntrain by ncall, right? So the numeric matrix, for consistent naming, let's call it train inputs mat. The next argument is this train label pointer down here. So let's call that a numeric matrix train label vec, because there's a vector of labels in the training data set that we need to pass through. And after that, we have a bunch of integer arguments some of which can be inferred from these first two, right? So the entrain and call can be inferred from the dimensions of the first two numeric vectors. So we don't need to include those as arguments here. Actually, we shouldn't. But we need to include this third one, max neighbors. So let's do that. Int max neighbors. And so max neighbors is going to be the maximum number of neighbors that we want to use for prediction in nearest neighbors algorithm. The next thing, and test, this is going to be the number of observations in the test set. And so that's going to be basically the size of this matrix here. So here we're going to have a numeric matrix test inputs mat. And here let's correct this because actually this label is a vector, not a matrix. And after that, here we have weight pointer. So this is a vector of weights for all of the training data points. So numeric vector train weight vec, right? So here the argument is down here at the bottom, but for consistency we might put it I don't know, if to keep all the train arguments together, we might put it up there. And finally, the last argument down here, this is an output, so we're not going to return that. I mean, we're not going to input that, we're going to return that. So what are we going to do now? Now we have to create a function called, it's calling this predict one to max neighbors matrix function. So first of all, the return value is integer status code. So let's store that as a variable called status one, and then we're going to call the one to max neighbors matrix function. And what we're going to do is we're just going to pass these guys through. So here we're going to be, this is going to be train inputs mat 0 address of. And so what does that mean? I mean, so this numeric matrix here that we've created up here, the train inputs mat, that we're accepting as an input argument. Well, it's going to provide several different accessor methods. The square brackets operator gives us the element, sorry, the first double precision number in that array, and then the address of there, that'll give us the address or the pointer to that first element. So we're going to use that idiom to pass those pointers through. So the next thing is going to be the address of train label vec 0. And so the next thing in train, so that's going to be that's going to be this. We can get that by looking at train inputs mat.nrow. That's the number of rows, number of train observations. Next thing, train inputs mat.ncall. That's going to give us a number of columns, a number of features in the training data set. After that, max neighbors we can just pass directly through. And test, well, we can use test inputs mat and row to get the number of observations in the test set. The test inputs pointer, the next argument, so we can do test inputs mat 0 address of, right? After that, weight, so train weight vec 0 address of again. And so the last thing, this test predictions pointer, so for the outputs we need to do an allocation. So let's, basically we're going to create a numeric vector like this up here. And let's call that, for consistent naming, test predictions vec. And actually, instead of using this create function, what we can do instead is just tell it the size that we want. And so the number of test predictions is this thing right here. So let's call that nTest. And let's make that a variable. And that's going to be InTest, a vector of size InTest. And so then what we can do is we can just pass a reference to that, test predictions vec. And then after that, we can just return that test predictions vec. Is it a vector? Actually, no, it's a matrix, right? So here it should be a matrix of size max neighbors by InTest. So let's do that. Let's change that numeric matrix test predictions map, and it's going to be size max neighbors InTest. Test predictions map. So already, you know, we've written some code that basically, to summarize, I mean, we started out with a definition of this C++ function that we wanted to interface. All we have to do is we have to figure out which are the inputs and which are the outputs, and then create, you know, basically input arguments to our interface function for all of the corresponding, you know, pointers in the inputs over here. And then for the outputs, we have to do a memory allocation using this numeric matrix function. So let's try to compile that and see what happens. So actually, I think we should probably get an error because there's no references to this function yet. So let's see. Predict 1 to max neighbors matrix was not declared in the scope, indeed. But it is included in the knn.h header that we have here. So let's see if that fixes the problem. No, we still have some error. So it says could not convert test predictions map from RCpp numeric matrix to RCpp list, right? Okay, so we're still using this list thing here that was included with the RCP package skeleton. So let's change that to numeric matrix so it's clear, so the types are consistent. Also note that we haven't done any type checking, you know, so here the integer status code may tell us that there was an error, but we haven't done the error checking yet. So package or namespace load failed for NRCPP. And so what's going on here is that we haven't rerun the compileAttributes function. So whenever we update our C++ source code that is decorated with this RCPP export stuff, we need to update the corresponding. We need to run compileAttributes, which will update the other automatically generated source files. So let's do that. So here it should be, instead of just running R command install, we'll first run our r-e rcpp compileAttributes, and then run r command install. So let's see if that works. Go interface. Whoops, interface. Yeah. Okay, so it says error in RCPP compileAttributes package dir must refer to the directory containing in our package. So indeed, so we have to actually use, you know, in our dir-locals thing, we have to actually do a, the coding is kind of tricky, but here I'm going to use embedded double quotes. And the idea is we're going to do this to that R package. So let's see if that works. So the RCP compileAttributes is actually doing something now. it actually generated a new RCPP exports file. It had to recompile that thing. And it looks like the code is compiling, and the code has now worked. Sorry, the code has compiled. So in the next screencast, I'm going to show you how to run that code.